Hi, and welcome to our ongoing mini web seminar series. Today's topic is embedded DevOps with simulation. Today, we're going to cover several topics: the importance of DevOps to software development, the importance of embracing DevOps if you're building an embedded system, and a little bit about how you can achieve the objectives of embracing DevOps and beginning to realize some of the benefits of that technology. Over time, we've solved complex problems through automation, whether it's building inexpensive furniture or building a complex system. As long as you had the right tool and a set of repeatable instructions, it was possible to overcome just about any challenge. Software is no different. So, what we've discovered over time is that a set of repeatable steps will help you build, test, and deliver software more quickly and with higher value and quality to your customers. We think about the why of this. It's actually pretty simple. Just about every system, no matter the industry that you operate in today, is actually being driven by one simple maxim, and that is software is eating the world. More and more value in just about every solution is being delivered through the software itself, rather than just the hardware or just the know-how embedded in a company. So with this increased value in software comes increased complexity because the systems themselves are more difficult and they contain more content. And therefore, the traditional ways of developing, testing, and delivering software need to keep pace with this new dynamic. Several industries, not the least of which is IT and some of the services that you probably rely on a daily basis, have already embraced DevOps as a culture, and they've seen some surprising benefits from doing so. Probably the most relevant thing is speed of delivery. So if you're delivering value in software, the more quickly or the quicker that you can get that software into the hands of your customers, the more relevant you become. So IT and service industries have now begun embracing DevOps, and they've seen, at least in the study that I'm quoting here, up to 440 times faster delivery. So any single change can actually be pushed through the DevOps pipeline and delivered into the hands of customers much more quickly. You would think that by increasing pace, you would actually lead to lower quality. But in fact, what these companies have discovered is as they go faster, as they embrace automation, as they change their way of working, they're actually decreasing the number of defects that they've found by about a fifth, 20%. But they've also been able to recover more quickly as well. So in this case, 170 times faster because of the way that DevOps works. Things that aren't broken move through the pipeline. Things that are broken get addressed relatively quickly by skilled teams of analysts who figure out what was wrong, fix it so that it doesn't happen again. And over time, that muscle memory, that improvement over your process, that improvement of software testing and delivery results in huge benefits. So why shouldn't the embedded world benefit from this as well? So today we want to focus a little bit on how. How are we going to make DevOps and this continuous integration and delivery possible for embedded development? Part of it is embracing the culture of DevOps. It's been very successful simply by embracing this idea that if something fails, there's no blame assigned. You just do your root cause analysis and you fix it for the next time. The challenge for embedded software teams really comes down to a couple of things. First, embedded development is inherently challenging. Most of the time, you're not simply building something that runs on another piece of hardware that's similar to the one that's sitting on your desktop. You have to manage cross-platform development so that you can target your end goal. It's also tricky to test. It's challenging for a number of reasons that we'll get into later in the slide deck, but let's be honest, automated testing is a critical component, automation in general, but automated testing specifically is a critical component of DevOps and problem resolutions. Now, here's the good news. All of the challenges that I've just alluded to can easily be overcome as long as you have the right tools and the right set of steps. Some of the challenges that we're going to cover throughout the rest of this presentation revolve around how teams can collaborate effectively in a DevOps culture, but also how tools can be automated and put into a DevOps pipeline, and then access to those tools can be facilitated. These are not simple challenges when we're talking about embedded development. And they're not simple challenges when we're talking about DevOps for embedded development, but again, they can be overcome. So specifically, let's think about access. If you consider that you're taking a piece of software and you want to take one small change that's been committed into a source code repository, then move that change through your DevOps pipeline, a number of things are going to have to take place. The code will have to be built. The code will have to be validated against a set of quality criteria. We'll call that test for the purposes of today's presentation. The quality may, the final product may have to be delivered and then at some point shipped to a customer. One of the bottlenecks, though, is the availability of target systems. So if you have to wait for access to physical equipment to test on, that can slow down the pipeline to the point of being not very useful. If you have multiple variants of the same piece of hardware, setup and configuration can be a problem. And if you are interfacing with actual hardware, imagine the challenge and the complexity of setting up a test lab that's capable of serializing access to that complex and expensive hardware. So it's tricky. Access is a key challenge. Has to be overcome, but so does automation. So whenever you hear a manual process in a DevOps pipeline, you're probably not quite there yet. Manual processes simply don't scale. There can be manual intervention when a particular change moves through the pipeline and fails. In fact, that's what you want to have take place. But if there's anything manual inside a DevOps pipeline, it won't scale to the level that you're probably hoping. And it's not just testing software. You might have to test hardware as well. Once there's an access problem, once there's a challenge around getting access, then you might not have enough testing to maintain the quality and security that you're trying to achieve by embracing DevOps. And remember, the idea is fix the problems as they arise so they don't happen again. If you can't test, if you can't automate, that's going to be a big problem. The other challenge, of course, is how does one react to a failure? They will occur, and that's okay. But if you don't react properly and quickly enough, the overall velocity of your pipeline is going to decrease. People will lose faith, they'll find workarounds, they'll stop doing it, something else will happen. So part of how one has to get there, of course, is have good collaboration tools. You have to be able to share data, assets, what's gone wrong, log files, dashboarding. You have to be able to get cross-functional teams to work together efficiently in order to do that root cause analysis and to make sure those problems don't occur again. And part of the thing that hamstrings embedded developers and embedded companies is that a lot of the tools that they use and rely on today really aren't designed for testing complex systems through automation and through DevOps pipeline itself. So there's some challenges here. The hits, of course, are, at least on the access side, you got to pay a lot of money to buy your equipment. So that's a CapEx hit. But slowing down or not being able to embrace better automation and better collaboration is a hit to your operating expenses. So there are consequences to not being able to do this. Delayed time to market, which delays your revenue, increased development costs, lost market share, or perhaps the loss of a market. So there are good reasons to overcome these. And again, DevOps really is possible for embedded development. So how do you do it? How do you make sure that the DevOps pipeline itself, that series of automated steps, has access to the required platforms so that you can automate test? How do you make sure that there's an effective communication, an effective flow of data and collaboration across teams? And how do you make sure that that test automation fits into your DevOps pipeline and that workflow that you want to achieve? So one solution, and the solution that I want to focus on throughout the rest of this presentation, is Wind River Symix. So what is Wind River Symix? It's a full system simulator. It allows you to simulate the hardware of complex electronic systems. And it does so by taking the physical hardware, the stuff that you might actually have to put into a server room, manage and control the physical devices. It converts those into virtual platforms that run on standard hardware. So the very same servers that might be hosting your software repository or your build tools can now also run the virtual platform that represents the hardware itself. The beauty of a virtual platform is it can be as big or as small as you need it to be for the test in question. So if you need to simulate a single processor running a particular workload, that's fine. If you need to simulate a network of these things, that's also possible. To help facilitate the any kind of root cause analysis of any problems that might arise, the same binary that will run on your physical target will actually run unmodified on the virtual platform running inside Symix. Plus, there are a number of unique and powerful debugging techniques that we'll talk about momentarily that can help teams collaborate more efficiently. And remember, that's one of the key precursors to being successful with DevOps. If we take a quick look at some of the features of Symix, let's just consider the possibility that as a change moves through your DevOps pipeline, something goes wrong. So what tools does Symix bring to the table to help teams figure out what happened? Well, the powerful features at the top of this slide are things like the ability to take an entire system and stop it. So rather than having a number of different components running in parallel, then you find a problem, you create a breakpoint, you stop the system, but the rest of the system keeps running. It makes it difficult to actually to control the system and do your root cause analysis. With Symix, I can stop the entire system. Once I figured out what's wrong, I can move time forwards and backwards until I find the exact problem and fix it. And every time I run my Symix test, it's going to be exactly the same. The repeatability will always be the same. So I don't have the experience of, well, it works on my machine. That doesn't help when I'm trying to debug a problem that's actually occurring on a server somewhere. Finally, the ability to look into and understand the system at any given point in time allows teams to do that root cause analysis in the event of any kind of problem. Symix also allows you to create a full system checkpoint and restore. So what that means in combination with scripting and automation in a DevOps pipeline is, imagine that a problem occurs. I want to take advantage of some of the capabilities around debugging. My automated script can create a checkpoint and mail that checkpoint off to anybody in my organization, regardless of where they are in the world. So if I need a specific expert to take a look at what went wrong, I can create the system checkpoint, which gives me the full context, mail it to that person, email it to that person, and he or she can then dig in and with complete determinism, repeatability, and reverse execution, narrow into the actual problem. So this ability to plug Symix into the DevOps pipeline and also take advantage of some of these more powerful capabilities through scripting and automation really helps unlock the full potential of embedded tests. The other power that Symix brings is, imagine having an automatable 24/7 test lab available to any engineer or any tester anywhere around the world. That's the power of a virtual platform. Rather than having to manually configure and create a lab that has actual hardware and some kind of orchestration layer on top of access, Symix virtual platforms can run at any scale and be available 24/7. This is really one of the key benefits that Symix brings to a DevOps pipeline. It takes away that bottleneck of access. And again, as we talked about in the three big challenges, that's a big roadblock to overcome. So let's take a little bit of a little deeper look or a deeper dive into the solution itself. So as I mentioned, solving the access problem with the 24/7 worldwide available and stable test lab is a very powerful capability. Everybody has access to the system and they're all sharing the same artifacts. Configuration and setup is very simple, at least compared to physical hardware. I could have one virtual platform that represents the first variant that I want to test. And rather than having to have a second dedicated piece of hardware, I could simply reboot the virtual platform with different parameters or stand up another virtual platform to represent the second variant. It's all software, so setup and configuration is simple, and I have nothing to RMA if the hardware goes wrong. The automation side allows me to automate the tests, to profile or trace the tests, to generate information at any time I need. So automation is key to successful DevOps culture and to a successful DevOps pipeline. I don't need anybody to run the test once it's been defined. It can be run over and over and over again. And my test is taking place in the context of the full system rather than some sort of isolated test harness or in a mini model of something. The beauty of Simics running on a server, these virtual platforms, is that they can essentially scale without limit and tests can be run in parallel. Again, we don't want a bottleneck. Part of the value of our 24/7 test lab is automatic access. So the capability of virtual platforms is very high. As well, we talked a little bit about some of the capabilities of checkpointings, but rather than just saying the software failed here at about this time, in fact, I can send the entire context of the system when somebody needs to resolve a problem. So I can see the exact state of memory, registers, the rest of the system, and the software. On the collaboration front, we talked about sharing an exchange of executable data or saving the circumstance of test failures. I can't stress enough how challenging some of these systems are to test. So the ability to isolate a problem and resolve it quickly, even third parties, if you have external hardware or externalities, is really powerful. The core of the key value that you want to embrace with DevOps is quick, zero blame problem resolution. And these collaboration tools help you get there. So, put this differently, Simics is going to help you deliver software, better software, faster, and at lower cost. And that is exactly what people are trying to achieve with DevOps. So, how do we know this works? Well, we know it works because we do it ourselves. So, at Wind River, if you think about what our business is, we build operating systems and we build operating systems that target a wide range of hardware and many variants of that set of hardware. We have about 2,000 targets that we test against on all the versions of our different operating environments today in our test lab. We run tens of thousands of test cases daily. And frankly, the cost to maintain those physical devices for tests is quite high. It also slows down the testing and our release cadence if we have a number of testers and developers who are contending for the same hardware. So that was the problem that we were encountering. And what we've done to address it is to begin transitioning to Simics virtual models running on a server. So these numbers are actually a little bit low because we keep adding new targets and new board support packages. And I think these, at least in terms of the board support packages, we're probably off by a factor of 10 at this point. So we keep growing the number of target devices that we have running on servers instead of physical hardware. We run about 40,000 test cases just on those virtual platforms every night. And it's allowed us to run um, or to deliver quality that's much higher than it was before. Again, once you take away that bottleneck, you can run more test cases. Once you run more test cases, you're going to find more problems more quickly, and the end experience of your users will be higher quality. So, although it sounds counterintuitive that going faster will result in higher quality software, it truly does. So, what we've seen is, again, having access to that 24/7 test lab. We have developers around the world. Follow the globe DevOps model is, or follow the sun DevOps model is critical. We test at least 30% faster and probably faster than that. And the savings that we've seen simply by reducing the physical, electrical, and cooling costs in our labs are quite substantial, let alone the savings that we've realized simply by not having to buy and reacquire new hardware. Legacy hardware is also enormously complicated to acquire at times. And so having a virtual platform for test has been critical. So we've seen savings both in the speed of tests, the improvement in quality, OPEX and CAPEX savings, and that 24/7 test lab. So one of our test engineers said, you can have Simics back when you pry it from my cold, dead fingers. He wasn't joking. For us, this is a critical benefit, and we've embraced DevOps by the use of Simics, or partially through the use of Simics. So to summarize, everybody wants to go faster. Everyone wants to deliver software at the speed of relevance. We know that our customers need our solutions faster and at higher quality, and that if we can achieve those objectives, we will grow our business and bring more value to our customers. The way that you do that is by embracing and leveraging modern DevOps practices, automation, collaboration, and zero blame fixing of problems. You need to be able to automate your testing, automate access to your hardware so that you can do this in an embedded environment. It would be almost impossible to propose going faster with physical hardware, but with virtual platforms running on Wind River Simics, it is something that you can accomplish. And we have the stats to prove it at Wind River. So I want to say thank you very much for your time. I hope you found this session valuable, and I hope you'll join us for our next mini web seminars that will be coming soon. For more information, you can join us, visit us at windriver.com/simics to find some white papers and to take a look at some of the additional values of Simics itself. Thank you very much. I'll see you soon.